Welcome to this tutorial on building a CNN model in AI for identifying dental decay. Next, we'll define paths to the training, validation, and test datasets. These paths will point to the directories where our datasets are stored. It's important to note that you need a substantial amount of training images for accurate model performance. Ensure your images are segregated into folders, one for normal images and one for images showing decay. This organization will help in the proper training of the model. First, let's talk about the essential libraries we'll be using. TensorFlow and Keras. These libraries will be used for building and training our deep learning models. NumPy. We'll use this for numerical operations. PIL crucial for image processing. Next, we'll define paths to the training, validation, and test datasets. These paths will point to the directories where our datasets are stored. We'll start by augmenting our training images with random transformations using train_datagen. This helps prevent overfitting. For our validation and test datasets, we'll only rescale the images to ensure consistency. Now, let's load the images from their respective directories, rescale them to 150 by 150 pixels, and prepare them in batches. It's time to build our CNN model. Here's a brief overview of the layers we'll be using. Conv2D. These convolutional layers will learn image features. Maxpooling to D. These layers will downsample the feature maps. Flatten. This layer converts 2D arrays into 1D. Dense, fully connected layers to make predictions. Dropout. This helps prevent overfitting by randomly dropping neurons during training. Softmax. Our output layer will have 3 units, corresponding to our 3 classes. Adam. This optimization algorithm. Categorical crossentropy. This is our loss function for multiclass classification. Accuracy. Our primary evaluation metric. After training, we'll evaluate the model on the test data and print the accuracy to see how well our model performs. Finally, we'll define a function to predict a single image. This function will load and preprocess a single image. Predict the class of the image using the trained model. Convert the prediction to the class name and print it. Let's get started and build this model together. See, we have received a successful response. The image we uploaded has been processed and classified as normal.